community suffered some significant damage from a flash flood event which occurred.
That is unbelievable.
There was damage to properties, vehicles and people's houses. As horrific as this is for the communities that are affected, it gives us as researchers an ideal opportunity to go in our specially adapted vehicle and observe the processes and the impacts which are occurring following these events.
So you hear about a flash flood, you're heading there with this vehicle. Once you get there, you've got some great equipment to find out what's going on. Let's talk about what you've got here. First of all, we've set these up next to the river. What have we got here?
So what we've got here is, to the far left, a multi-station which is capable of producing really high definition surveys of the area where we're located. So to the right we've got a GPS station which provides us with a really high precision information about the location that we're at. So this is an ADCP. It's a boat which we're able to tether to the river and perform measurements.
All right, if it's a boat, it belongs in the river. Let's put it in there, shall we? Here we go. Oh, I know it's raining today. We haven't got a flood, but we have got a river to put it in. So let's set that up here. So talk me through the kit you've got on this.
So this is capable of providing really high resolution measurements of how fast the water's moving, the depth of the water, and also if there's any objects which are moving close to the riverbed itself.
So this is an augmented reality sandbox, and what we're seeing is a steep-sided catchment with a little village or town at the bottom. And what we use it for is to see what happens when we get an intense storm at one end of your catchment, and it will simulate water flowing down the catchment and flooding the village. And also it's useful because we want to know, are we getting these really intense events more frequently, and are they going to be even more intense than they are at the minute? And we can use that to put into our impacts models. So this is an example of an impact model where we're saying, if it rains so much, is it going to flood our town, and what defences can we put in place to protect the town?
Okay, so this is one of many different features which has been installed in the Hot Whistle Burn catchment, but for this actual particular feature it's different because of the size of it, so it's 60 metres long, but also because of how it's been inspired by the game Kaplunk. So in the game Kaplunk you've essentially got the straws which are bound together, and then the marbles trap within it. Well, here the logs within the system are actually acting like them straws and collecting stone and sediment which are washed away during a flood event. But we have actually had some rainfall events which are starting to show that the sediment is starting to pick up.
Oh, so already signs that this may be doing what it's supposed to do. Show me.
Yeah, I mean you can see the types of sediment it is starting to trap, so it's a bit like the marbles in the Kaplunk game, which would normally end up under the culverts in Hot Whistle.
So how encouraged are you that already, even at this stage, there are signs it may be doing what it's designed to do?
Well, obviously it's early stage. We are really waiting for a big event where the rainfall's heavy enough and in a short period of time where the system will get into full force and we'll be able to see how it performs.